Hello everyone. Today let's solve the problem number 17. Letter combinations of a phone number. So what the question states here, we are given a string digits. So you can clearly see here, we are given a string digits consisting of digits from 2 to 9. You have to keep this one in mind. Consisting of the digits from 2 to 9. They have shown in the figure as well. So consisting of the digits from 2 to 9, where each digit represents a set of letters like a telephone keypad. You can clearly see the figure here, right? So we are given a string digits consisting of the digits from 2 to 9, where each digit represents a set of letters like a telephone keypad. What is our main goal, or what is our main task here? Our main task is to generate all the possible letter combinations that the number could represent and return them in any order. Order doesn't matter. So we have to generate all the possible letter combinations that the number could represent and return them in any order. So I hope the question is completely clear. If we have given 2, 3, so we have to generate all the possible letter combinations that the number could represent, right? Here in this case, AD, AE, AF, BD, BE, BF, CD, CE, CF. So this is for the numbers 2, 3. So when we don't have any number, we have to return. I means when the string is empty or we don't have any number within the string, then we have to return empty array, right? So when we have the single number, all the characters that is present in the or mapped to that particular number should be the output A, B and C accordingly, right? With the diagram A, B, C, we have A, B and C. So I hope the question is completely clear. Let's discuss the approach as usual, followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's go with the approach. Let's consider this example for the approach. Let's discuss the approach now. So here, let's discuss the approach step by step. So let's break down the this one approach by considering the first example that they have given in the problem. This is what they have given. So output should be this one. So first thing is, we'll be making use of the backtracking here in this case, right? First, what we will do, we will map the digits to letters. So here we'll map the digits to letters. For the 2, we have ABC. For 3, we'll have D, E, F, right? So we are mapping 2 to ABC and 3 to D, E, F. That's what we are doing. So we need to generate all the possible 2-letter combinations where the first letter comes from ABC and the second comes from D, E, F. I hope this is clear. So we are just mapping 2 and 3 as they have given in the question here, 2 and 3. First thing is, we are creating a mapping here. I hope this is clear. So second step here is, we need to backtrack. So backtracking process, what we'll do here, we will be making use of the recursion. So we are going with the recursive backtracking. So we'll be making use of the recursion to explore all the possible letter combination. First, we will start with the letter. First, we will start with the digit 2 equals ABC. This one we have considered, right? This one, first one, and we will pick one letter at a time, and then we will move to the second digit and pick one letter at a time from this one. So if we are considering, so let's discuss this further. And when we reach the end of the string, we will store the combination. Just keep this in mind. So first, what we will do, we will start with the empty string. So I'm just considering the example one. So we will pick A from ABC. Initially, what we'll do, we'll start from the empty string. We will pick A from ABC. This is from the 2. 2 consists of here ABC and 3 consists of DEF. Can just check the diagram that they have given in the question. First example diagram they have mentioned, right? So A, will consider A from ABC, and we will add D from DEF. We'll add D from DEF, right? Now this will be AD. So same thing. Next step is, we will the first letter from the ABC remains constant, and then we will add E from DEF. A from ABC remains same. E from DEF. This will be AE. So next what we'll do? A remains constant. A from ABC. F from DEF. F from DEF. This one will be AF. So now we got AD, AE and AF, right? So next let's move on with the second letter in the ABC. Now we have considered DEF for A. Now we will go with B. We have to consider again DEF for B as well, right? B from ABC this time and D from DEF. So this one will be BD, right? Next step is B from ABC, E from DEF. This one will be BE. Finally, again B from ABC. This one F from DEF. So this will be BS, right? So this is fine. The final one is we have to consider. Now we have considered A, B. We are considering C and DEF, right? So this will be, let me consider C from ABC and D from DEF. This one will be CD and the C from again ABC, E from DEF. This one will be CE, right? Finally, C from ABC again and F from DEF. This one will be C and F. So these are the combinations that we got. So final result should be AD, AE, AF. So let me come here. Final result should be AD, AE, AF. We can write this one in any order. So I'll just write in the order that I got the output. So let me consider this one this one BD, BE, BF, right? BD, BE, BF. The from C what we got here? CD, CE, CF. CD, CE and finally CF. So this is the output that we got, which matches the output that they have given: AD, AEF, BD, BEF, CD, CE, C and F. So this is the output that we got. So the approach works absolutely correct, right? So this is the approach that we will be going with. Basically, the recursive backtracking. So I hope this is completely clear, right? First, what we did, we first created a mapping here. You can clearly see we created a mapping initially. The second step was we used recursion to explore all the possible letter combinations. We have started with the first digit, nothing but the 2, and we picked one letter at a time, and we moved to the second digit 3 here, and again we are picking one letter at a time from the 3, right? Nothing but from DEF in this case. So if we reach the end of the string, we are storing that combination. So this is the approach that we went with. I hope the approach is completely clear. Let's discuss all the edge cases. So let's discuss the edge cases one by one. So first edge case is for the condition empty string here. So when I say empty string, let me consider the input empty string. So the output will be here empty array. So because we have no digits at all, right? So here no possible combinations. When we have no digits, no possible combinations are possible. So I mean, yeah, no possible combinations. So here this is for the condition empty string. Let's move on with the second edge case. Nothing but in this case single digit. So when I say single digit, let me consider here 2. So 2 for this one, all the possible combinations are A, B and C. So this is fine. So here we have only one digit. So we are returning its mapped letters in this case. So let me consider the third edge case here. Third edge case is for maximum length case. Maximum length case, right? So this is for the maximum length case. Input, let me consider something like 7985, right? So we have to return all possible. So you can just try it out for this one the similar way that I showed by taking example 1 from the question, right? So this has to be the output. It has to contain all possible 4-letter combinations for 7, 8, 9 and 5. All possible 4-letter combinations, because we need to ensure the solution efficiently handles up to 4 to the power of 4. That is nothing but 256 combinations in this case. So max length case, this is for the condition max length case. So these 3 edge cases that we need to keep in mind. First one is for the empty string, second one is for the single digit, and third one is for the this one max length case. So I hope the edge cases are completely clear. Now let's start writing the code. So here, let's start writing the code. First thing is, if the input is empty, we have to return an empty array. This one we saw in the edge case. So how can we articulate this one in the form of code? So if not of digits here, this one. If input is empty, if not of digits, we have to return empty array in this case. This is fine. This is the first the edge case. This is one of the edge cases. So next thing is, if you remember, we were mapping the digits to their respective letters. We have to map the digits to the respective letters, right? That's what we will do here. Just consider here, let map equals. So what I'll do here, to let me consider ABC. So they have given in the figure. So what are the numbers here they have mapped? So it starts from 2, right? 2 to 9. So let me give here 2 ABC. Let me copy this one same. 3, 4, 5, 6, 7, 8, 9. Right? This is fine. Let me quickly change here. 3, 4, 6, 7, 8, 9. This is fine. This has to be B, C, D, E, F, G, H, I, J, K, L, M, N, O they have given right here. M, N, O, P, Q, R, S. So this will be P, Q, R, S. I'm just going with the diagram, right? Let's go with T, U, V here in this case. Final one is 9, W, X, Y and Z. So this is fine. What we have done here, we have just mapped the digits to their respective letters. I hope this is simple, right? We are just mapping the digits to their respective letters. Next step is we need result array. We have to store all the valid letter combinations, right? So we need the result array or the answer array. So I'll just consider here, let result, and let's initialize this one to the empty array. So now let's come to the main part. Let's make use of let's create the recursive backtracking function. So let me give here const backtrack. So I'll just pass the parameters I and path. So this is fine. The base case, we have already discussed this one. If we have formed a combination that is equivalent or that is equal to the length of the digits, then we have to store it. Again, I'm telling this was the base case and we have discussed this one by taking the example. If we have formed a combination equal to the length of the digits, then we have to store it in this case. So this is nothing but is I equals length of the digits dot length. Then we have to store it somewhere. Here we'll be making use of the result dot push. What we have to push? Nothing but path here. This is fine. I'll not return anything. I'll just give a return in this case. This is fine. So if we have formed a combination that is equal to the length of the digits, we have to store it. And after that, we have to get the possible letters for the current digit. So we have to get all the possible letters for the current digit, right? So I'll, I'll be making use of the for loop for this. C of map of digits. What did I give here? Digits. Iterated value of the digits. This is fine. Within this, we have to recursively call the function to build the further combinations. We need all the combinations, right? We saw that one examples. We need all the combinations. First, what we did here, for 2, we considered A, and then we considered D, E, F from letters D. So we have to recursively call the function to build further combinations as well. From 2, we have to consider A, B, C, and from this one, 3, here for this example, we have to consider D, E, F every time for the single letter from 2, right? So for this purpose, we are recursively calling the function to build further combination. So recursive function here, backtrack. Next, we have to move to the next one, right? I plus 1. Finally, path plus C here. This is fine, I think now. So this is it for this one. Backtrack function. I'll just come out of the backtrack function entirely. So we have to start the backtracking from the index 0. So this is common for the most of the problems, right? So when we are solving the backtrack problem, so we are starting here from the index 0 with an empty string initially, right? So how can we write that one? So let me give you a backtrack. So we are starting from the 0th index with the empty string. So I'll mention the same thing. Finally, we have to return the final result that contains all the possible letter combination. In our case, we have made use of the result here, this one. Somewhere, well done. So this one, right? We are just, we have returned the result because we have to return the final result containing all the possible letter combinations in this case. So let me format the code once and let me hit the run button. So here, what did I do? Unexpected syntax. Oh, I have given within this one. Okay, this one has to be comma everywhere. This is fine. Just give me a second here. Let me change this one to comma. This is fine. The last one we don't take. Anyways, so let me hit the run button now. Again error. Oh, digits I have misspelled here. The line number 18. This is fine. So yeah, now you can clearly see the sample test cases are getting passed. So let me hit the submit button now. Oh, runtime error. Map of digits of I is not iterable. So why? What's wrong here? In line number 23. So let's check what we have done. So what mistake I have done here is, here you can clearly see instead of 4 I have given 5 twice here. 2, 3, 4, 5. While typing I didn't type 4 at all, I think. This is fine. Let me hit the run button again. I hope this works correctly. Yeah. Now the sample test cases are getting passed still. So let's see. I'll just hit the submit button now. I hope this works, man. Yeah, now you can clearly see all the test cases are getting passed here, right? So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So here the approach that we went with here is this one, recursive backtracking or backtracking, we can just say backtracking. So what will be the overall time complexity here in this case? Overall time complexity would be big O of 4 to the power of n. Why it is 4 to the power of n here? Because each digit can have up to 4 choices and we go n levels deep here in this case. Each digit can have this one 4 choices and we go n levels deep. So that is the reason the time complexity would be big O of 4 to the power of n. And then what will be the space complexity here? This overall space complexity would be big O of n. And why it is big O of n here? Because recursion depth is at most n in this case. We are making use of the recursive stack, right? So recursion depth, we know that is at most n here. So overall time complexity would be big O of 4 to the power of n, and over space complexity would be big O of n in this case. So I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.